The fifth experiment in our syllabus is measurement of capacitance using Schering Bridge. The objective of this experiment is to understand the fundamental principle and operation of Schering Bridge for measuring the capacitance and to accurately measure the unknown capacitance of a capacitor using the Schering Bridge circuit and to calculate the dissipation factor of a capacitor, which provides insights to its quality. To analyze the valid results obtained from the bridge balance equation and to practice the balancing technique of AC bridges and understand the conditions for achieving balance. To correlate the theoretical concepts of AC bridges with the practical implementation for the real world application. And also to develop the skills in analyzing and troubleshooting the AC bridge circuits in the presence of errors or deviations. So now we are seeing the apparatus, that is the trainer kit of Schering Bridge. So this one is decade capacitance bus, which we are using to find the capacitance. So on the whole setup, so you can check. So there is a frequency oscillator. So this frequency oscillator is will be receiving the signal from the from the function generator. So there is a um, two potentiometers to vary the value of R4 and the value of R3. So we can change the capacitance value. We can select the capacitance value. There are three different values. By placing the patch cards in one of these positions, we can select the values. So we can so there is an amplifier, audio amplifier. So on the bridge balanced circuits, so the amplifier sound, by varying the sound, we can able to detect there is no, whether there is a flow of current or whether there is no flow of current. Okay, the detector will be connected to this audio amplifier, or also we can use this multimeter for measuring the zero current. Okay, so for balancing bridge, we can vary this R3 or the value of capacitance. Um, okay, so the decay resistance bus is used to uh, we can use the decay resistance DCB bus or else the unknown value capacitance. So which is used to have. Okay, so there is a values. So we are choosing the which to be converted from the value of from DCP, we are giving to the unknown capacitance Cx. So the detector, so we are making the first aim is we have to measure the values under the balance condition. The balance condition, the detector should be display the value zero current. So now we are making giving connections to the circuit. So from A to A, then B to B, and also we need to give connections of the dotted lines, those which are the shorted forms. We have to ensure that whether all the uh, whether all the connections are given properly and the circuit is being get closed. So when the circuit will be closed, then only there will be a flow of current and we can able to conduct the experiment. Okay, now I'm giving the connection from the decade capacitance bus to the unknown value capacitance. Okay, so for the examination side, they will be pasting the paper that so that you cannot able to see the value of the capacitance. Okay, or they will be giving the capacitor itself. Okay, So we can do the experiment even with the capacitor or the DCB bus. For to measure the various capacitance, I am using DCB, but we can conduct the experiment using a single capacitor also. Okay, there is a part. So this by making by adjusting these various two parts, we can uh, make able to zero, or we are going to make zero in the, that is in the connector we are making zero, or else instead of audio amplifier we can also use the multimeter to measure the current. So now from this we are making to zero by varying this potentiometer. So once the bridge is balanced, we have to measure the uh, value of this R3, so which is displayed in this multimeter. We can measure this value of R3 capacitance, so which is displayed as 78.9. So here this R2 value is 15.5. So um, so we have to do this calculations. So the formula is Cx is equal to C2 into R4 by R3. So the unit of capacitance is microfarad. So the value of C2 is just as 0.1. From the tabulations from the taken reading, we have chosen R4 is 15.6 and we have observed the reading of R3 as 79.1. So the Cs is equal to 0.01. So the dissipation formula is omega C4 R4. Omega is equal to 2 pi f and C4 value is 1000 and R4 is 15.6. So we can calculate these values. Okay.